Hi, and welcome to part 2 of SQL. I hope you watched part 1 where I discussed database terms and SQL examples on an online platform. I'd also provided links in the description there for all the examples that I did. In part 2, we'll begin by downloading MySQL Server software and use MySQL Workbench along with IDLE Editor. We'll also briefly discuss the data control language commands, grant and revoke. We'll then look at JupyterLab along with SQLite. In the description of this particular video, I'll be providing links to the codes which you can copy, paste, and use on your own computer since they will not work on the online platform. Happy watching. You can download the MySQL server by going to this website, and the link for this website has been provided in the description. You can choose the operating system from this drop-down list and click on download. On this page, it will ask you to either sign up or log in. But you can also choose no thanks, just start my download. When you click, it will automatically download the installer on your computer. Depending on your computer, this may take a little while to download. And once it's opened, it will give you the setup wizard. It will also ask you permission to download this software. You can click on yes. Once you start installing, it will ask you to choose a setup type. You can choose full and click on next. The next step in the installer is to check requirements. If you click on the execute option here, it will scan for various software requirements and install automatically. Notice that this installer will also install your MySQL Workbench automatically and also give you a Python connector, which will help you create a database. Choose the standalone MySQL Server option. You'll now be asked for a password for the root account, which is the default account. And remember that this is the password you'll use later to open the MySQL Workbench server. Once the configurations are completed, you can click on Finish. Once the installation is completed, the installer will then check the connection to the server and it will ask you for the password. If the connection is successful, it means that you can start working with the MySQL Workbench server. Once the server is downloaded, you'll see the MySQL option in your Start menu. And in this, you will also see the MySQL Workbench option. You can pin this to the taskbar and open to check the Workbench. There'll be the root instance of the MySQL server. You can click on that. It'll ask you for the password that you used during setup. When you fill that here, when you open the MySQL Workbench, you'll see options Administration and Schema. When you click on Schemas, you'll see the databases that are there in this Workbench server. If you've created one yourself, you can see that here, and you can also see the tables within this database. Now to click on the table and see the structure of the database, or you can click on the grid view and see the data inside the table. We'll start by writing a program in IDLE to create a database. And to do that, we first need to connect to the MySQL Workbench server. So for that, we import MySQL.connector module and use the connect method from this module. We'll pass host, which is localhost, user, which is root, and password, which you've specified while you installed MySQL Server software. And once we've done all three, we're going to assign this to a variable mycon. Now, you can use any variable name here, and we'll use that same variable to create the cursor object using cursor method. Once we've created the cursor object, we're going to use the execute method, to which we are going to pass an SQL statement, create database, give the name of the database, and once we run this program, this database will be created. Now, In case we want to check whether the connection was actually created, we'll use the is_connected method with the if statement. Now here we are going to print you were connected and the database was created if this is true. We'll also then close the cursor object and we'll close the connection. Now this is a good thing to do so that you free all the resources. We'll save this file as smartwatch.py and we'll now run this module and it says you were connected and the database was created. Once the database is created, the next step is to create a table within this database. We start again by importing the MySQL.connector module and we're going to use connect method. Now we're going to pass 4 parameters, that is host, user, password, and database. So the host is localhost, user is again root. The password is the password that you're using for the root instance. Database is the one in which you want to store this table. We'll also create the cursor object. We're going to use the execute method to which we'll pass the SQL statement to create a table. So we say create table. We give the name of the table watch. The watch ID here is the primary key of data type char. We have the attribute name, which is varchar, and we have price, which is int. We have the quantity in store, which is int again. We'll also use the is_connected method to check whether the connection was actually made and the table was created successfully. And if it was, we're going to use the close method to first close the cursor object and then the connection. We'll save this file as watch table.py and then we run this module. It says the watch table was created successfully and the connection was closed. Once the table is created, we need to insert data into this table. And to do that, we'll first connect to the server using the module MySQL.connector. We'll use the method connect to which we'll pass the 4 parameters host, user, password, and database. We'll create the cursor object once again, and we'll use the execute method to which we'll pass the statement insert into watch values and give the values according to the attributes. Now here we've given values for 6 rows in the table, and then we use the commit method, which will actually ensure that all the values in these statements are put inside the table. And then we use the is_connected method to check whether this was done successfully or not. We'll close the cursor object. We'll close the connection once again. We'll save this file as watch data.py and then we'll run the module. We'll see that the records were inserted successfully into the watch table and the connection was closed. Once we've created a table and inserted data into the table, we can use the select statement along with the fetchall method to see all the records. We'll start by connecting to the web server, for which we'll import MySQL.connector. We'll use the connect method to which we'll pass the 4 parameters, host, database, user, and password. We'll create the cursor object and we'll use the SQL statement. Now this time we are saving the SQL statement in a variable and passing that variable to the execute method. This is another way of doing this. We also use the fetchall method to fetch all the records, and we're going to use a for loop to present the results. So once we've done that, we are going to close this database and we'll save this file. When we run this, we'll see that It'll output all the records from the watch table. We can also output one record at a time. We'll use the same SQL statement, but in this case, instead of fetch all, we're going to use fetch one. We'll save this file and we'll run this. So we'll see that the first record from the table is output. We'll now use the update command to update records in the watch table. We start by connecting to the MySQL server. To do that, we import MySQL.connector, use the connect method. We are going to pass the parameters host, database, user, and password. Create a cursor object. We're going to use the SQL statement update watch, set price equal to 65,000, where name equal to Apple Watch. We use the execute method to execute this SQL statement, and to make the changes permanent, we use the commit method. We also use row count to check how many rows were actually updated. We'll save and run this module, and we'll see that one row has been updated. In case we run this module once again, it'll give us the output 0. Since no more updation has happened, this updation is already there, so no other change has happened. We can open the MySQL Workbench server and check whether the changes actually took place in that table or not. We'll open the smartwatch database. We'll open the table watch, and we'll look at the data of the table, and we'll notice that in case of Apple Watch, the price is now changed to 65,000. We're now going to use the command delete from to delete a record from the watch table. We start by connecting to the server. We use import MySQL.connector. We use the connect method, to which we are going to pass the host, database, user, and password parameters. We're also going to prepare a cursor object using the cursor method. We're going to use the statement delete from watch, where name equal to Carmen Phoenix. We'll use the execute method to execute this statement, and we'll use the commit method to make the changes permanent. We also use row count to see how many rows were deleted. We save this module and then we run it. And we'll see that it's deleted one row. We can now open the MySQL Workbench and check database smartwatch. We'll see that the watch table does not contain the watch Garmin Fenix. We'll now look at data control language commands, which we had briefly discussed in part 1 of SQL. These are commands grant and revoke. In order to grant privileges, we start by creating a user. We give the SQL statement, create user, give a name to the user identified by, and give a password. When we save this file and we run the module, we'll see that a new user was created. Once we've created a user, we can grant privileges to the user. We can say grant all privileges, or we can give specific privileges like select, update, delete, and then we say on, and then give the name of the database dot the name of the table on which you want to give these privileges. Then we use the keyword to and the name of the user. So once we do this, we can save this file and run the module. We have all rights granted to this user. If we want to revoke the privileges given to the user, we use the SQL statement revoke all privileges, or whatever privileges were given on smartwatch is the name of the database, dot the name of the table, and from keyword with the name of the user to follow. When we save this and run the module, we'll see that all the rights have been now revoked. I'm now going to demonstrate SQL commands using JupyterLab and SQLite. SQLite is a library that implements a fast, self-contained, highly reliable, and fully featured SQL database engine. And it is the most used database engine in the world. SQLite is built into all mobile phones and it comes bundled with the Anaconda Navigator software, which contains the JupyterLab. So we don't really have to download this software. We'll open JupyterLab and create a new notebook. We rename this notebook as student. And once we've done that, we'll import the library SQL Alchemy, use a create_engine method to which we'll pass a string. Now, it starts by writing SQLite : 3 slashes, and then we can give whatever name we want to give to our connection. So once we pass this connection string and run this, we'll have created a new connection to the SQLite engine. We're also going to use something called magic commands, which are commands in the IPython SQL library. And to do that, we start with the magic command load_ext SQL. When we run this, we may not get any output. We can go ahead and use the magic SQL command. Notice that the magic commands always begin with the %sign. A single line magic command will help reduce lots of lines of code, including importing libraries and other commands. We can use the magic command with a single %sign if it is a single line command. If there are multiple lines of code in that same cell, we'll use 2 %sign. You'll see this in the examples ahead. We can use the magic SQL command to create a database. So we call it once the database is created, we can insert a table inside the database. We are again going to use the %SQL, that is the magic SQL command, and we are going to use create table, give the name of the table as student details, and here we are going to write admission number as primary key, name, age, city, and score. When we run this, it adds this table to the database. We are now going to add multiple lines of records inside the table. So in this case, we are going to use the magic command SQL with 2 %signs, and we're going to give multiple lines of code. When we run this, we'll notice that all these rows have been added to the table. We can then use the magic SQL command along with the SQL statement, select star from student's detail. And when we run this, it'll give us the output of all the records that are inside the table. We can also update a record in this table using the magic SQL command along with the SQL statement update student details, set score 395 where admission number is 1008. When we run this, we'll see that it has affected one row. Check this out using the magic SQL command along with the select When we run this, we'll notice that for admission number 1008, the marks have been changed to 395. You can also use the magic SQL command along with a delete statement, delete from student details where admission number is 1010. When we run this, it shows one row affected. We can always check this out. We'll use the magic command again, along with select star from student details. we'll notice that the record 1010 no longer exists. To demonstrate equijoin and natural join, we need to create another table. We start with the magic command SQL. We'll write create table sports team, give the sports ID as primary key, admission number, name, age, and game. When we run this, we'll see that the table is created. We can now insert data or populate this table. We are going to use the magic command. Because it's multi-line, we are going to use double percentage signs, and we're going to insert values into this table. For equijoin, we are going to use the magic SQL command with the statement select star from student details, comma, sports team, where students details dot admission number equal to sports team dot admission number. When we run this, we'll see that all the records from both the tables which are common are displayed. Notice how it's renamed the common fields in both the tables. We're now going to demonstrate the natural join. We'll use the magic SQL command along with the statement select star from student details natural join sports team. When we run this, the output shows all the records which are common to both the tables, but there's no duplicacy. Well, that brings us to the end of SQL Part 2. In these two videos, I've tried to cover the entire portion for databases in a simple form. I hope you understood, and I hope it proves useful. Do keep watching for more interesting and simple videos, and do subscribe.